Okay, assalamu alaikum everyone, and very good morning. So now I'm going to start my class. What's the problem? In our last class, we were discussing about the triacyl glycerol and others. If you have any question, we can discuss before starting the class. Have you any problem or any questions about the class that we discussed lastly? If you have any question, we can discuss. Then I will start to this class. Have you any problem? তোমরা কি আমার কথা শুনতে পাচ্ছ? আমি সবাইকে আনমিউট করে দিয়েছি, সো সমস্যা নাই, প্রশ্ন জিজ্ঞেস করো। সরি, অ্যালাউতে দিলাম। ইয়েস
স্যার, একটা কোশ্চেন ছিল স্যার।
হ্যাঁ বলো
স্যার, নিউট্রাল লিপিডটা স্যার কি স্যার?
নিউট্রাল বলতে কি বোঝায়?
স্যার নিরপেক্ষ।
নিরপেক্ষ কিসের পয়েন্ট অফ ভিউ থেকে নিরপেক্ষ হবে? একটা অ্যাসিড অ্যাসিড কখন নিরপেক্ষ হবে?
স্যার যদি কোনো আয়ন না থাকে।
এই তো, ঠিকই তো, সেটাই তো
স্যার। মানে নরমালি মানে ওটা অ্যাসিডের জন্য ইউজ করা হয়েছে, তাই না স্যার?
ইয়েস, ফ্যাটি অ্যাসিড।
ওকে স্যার।
নেক্সট
স্যার, ফল ও ফুলের সুগন্ধের কারণ হলো বিভিন্ন এস্টারের উপস্থিতি। স্যার হচ্ছে তাহলে লিকুইড কি স্যার, লিপিড কি স্যার সুগন্ধ আছে স্যার লিপিডে?
সুগন্ধি যে সমস্ত কম্পাউন্ড, অ্যারোমেটিক কম্পাউন্ড, দে আর স্টেরয়েড লাইক কম্পাউন্ডস, আর স্টেরয়েডস আর লিপিড। সো লিপিড সাধারণত লিপিডেই ডিজলভ অবস্থায় থাকে। সো যে সমস্ত গ্রন্থিগুলো থাকে ফুল ও ফলে, এই সমস্ত গ্রন্থিতে যে সমস্ত লিপিড লাইক কনস্টিটিউয়েন্ট থাকে, যাদের ভিতরেই তোমার এই ফ্র্যাগনেন্স গুলো ডিজলভ অবস্থায় থাকে। ক্লিয়ার
স্যার?
Okay, now we are going to start our today's class, that is physical properties and chemical properties of fats and oil. Fats and oil have different types of properties. They are broadly classified into two types. This is the physical properties, and then in the সৃষ্টি 235 রেসপন্স করো। 235 আইডি নাম্বার।
স্যার আসসালামু আলাইকুম।
তোমাকে মেসেজটা কি করতে বলেছে?
স্যার আমি একটু পরে ঢুকেছি তো আমি জানতাম না, আগের ক্লাসে আমার মিস হয়েছে এজন্য।
এটা অটোমেটিক, তুমি কয় মিনিট ক্লাসে আসো এটা অটোমেটিক এখানে কাউন্টিং হয়। সো সেখান থেকে আমি অ্যাটেন্ডেন্সটা দেখে নেব তুমি আপ টু ডেট ক্লাসে ছিলা কি ছিল না, ওটা ওইখানে লিস্ট থেকে খুব সুন্দরভাবে বোঝা যাবে। সুতরাং এখানে অ্যাটেন্ডেন্স দেওয়ার বা আইডি নাম্বার লেখার কোনো মানে নাই। তুমি যদি প্রথমে ঢোকার পরে যদি 1 মিনিট পরে এখান থেকে লগ আউট করে চলে যাও, সেটাও কিন্তু আমার কাছে সেই ইয়েটা আছে, রেকর্ডটা আছে। মনে করো না যে তুমি আমাদের নখদর্পণে নাই, তুমি আমাদের অবশ্যই নখদর্পণে আছো। কয় মিনিট থাকছো, কয় মিনিট যাচ্ছ, কয় মিনিট আসো, কয় মিনিট নাই, সবকিছু আমাদের কাছে রেকর্ড আছে। সো বি কেয়ারফুল। আর এই সমস্ত চ্যাট বক্সে মেসেজ করার কোনো মানে নেই, কোনো দরকার নেই, ঠিক আছে?
জি স্যার।
Okay, now we are moving to discuss about the physical properties of fats and oil. We know about the physical properties, that means without using any kinds of chemical reactions, a fats and oil can be identified based on the properties that is called physical properties. So what are the physical properties? First, the freshly prepared fats and oil that you extracted from different types of source. It may be plant or it may be animal. If you extracted any fats and oil, if it is very healthy fat and oil, then you will find it colorless, odorless and tasteless. A healthy fat have no any color, have no any odor, have no any taste. But if some foreign material substance is added to it, that is called fortification, then a fat may be after this is color, it may have some color, odor and taste. But if it is not added, then the freshly prepared fats and oil will be colorless, odorless and tasteless. In the soybean oil that is available in your market, it is slightly yellowish in color because it contains some sort of the vitamin A and D. You know, the color of vitamin A is yellow in color. So some kinds of the vitamin A is added to it. That is why it is fortified soybean oil that is present in the market. But when the soybean oil was extracted from the soybean seed, it was colorless, odorless and tasteless. Then its specific gravity is less than 1. For this reason, fats and oil can float on water as its specific gravity is less than 1. Then insoluble. All of the fats are not insoluble in water, but the short chain fatty acids that are also soluble in water. But if you declare a compound as the fat and oil, so you have to think that its carbon number is more than 16. For this reason, all of the 16 and more carbon containing fats and oil are insoluble in water. So this is where insoluble in water. As fats and oil are organic in nature, so they are obviously soluble in different types of organic solvent like methanol, ethanol, butanol, propanol, benzene, chloroform, acetone, etc. Melting point is usually low. Melting point is usually but higher than the solidification point. So a fat is melted by applying a range of heat, but when the temperature is removed from this fat, the soluble fat become solid within a very low temperature. For this reason, the melting point is very low, but solidification point is high. Chemical properties of fats and oil. Those are the physical properties of fats and oil. Now we are going to discuss about the chemical properties of fats and oil. Chemical properties mean the properties that is worked out by applying a vast of the chemical reaction. Based on some chemical reaction, the specific reaction that is happened in the fats and oil, that is not happened by the other bioorganic compounds or biomolecules. The properties that is shown by the fats and oil only, that are the chemical properties. I mean, a vast of chemical reaction is applying on these fats and oil that are very much specific for fats and oil. Based on these properties, the fats and oil can be identified, and these properties are called the chemical properties. What are they? First, hydrolysis. Hydrolysis means in presence of water, the fat is broken down. Lysis means broken down, hydro means water. So in presence of water, the fat will be broken down. Where there is a chance to break the fats and oil, where it contains the glycerol or alcoholic group with the fatty acid. That is ester linkage. We know fats and oil contains two compounds. One is alcoholic compounds or glycerol. Another is fatty acid. This fatty acids linked with this alcoholic compound or glycerol by the ester linkage. So when the ester linkage is broken down in presence of water, this process is called hydrolysis, and the hydrolytic product will be fatty acids and glycerol or alcohol. So this hydrolysis may be happened due to different types of agent like superheated stream, alkali, acid or enzymes. So Without enzymes, if you want to break down the ester linkage of a fat, you have to apply superheated steam, very much extreme acid or extreme alcohol. And this condition, without this condition, living organisms can also make the hydrolysis of the fat by using an enzyme that is called lipase. I repeat, this enzyme name is lipase that affect on this ester linkage of the fat, and the ester linkage is broken down and fatty acid and glycerol or alcohol is produced. But if you want to do it physically without using the enzyme, then you have to apply superheated steam, alkali or acid. The product is glycerol or free fatty acid. That is fats and oil. We know it. This is very much usable neutral fat, usable for animal body. The fats and oils that contains the glycerol and fatty acid. And instead of glycerol, it may be different types of alcohol also. So this is the process by which the fats and oil undergo hydrolysis in presence of this physical agent or chemical agent, and the ester linkage. This is the ester linkage that is present between the fatty acid and the glycerol. Ester linkage, fatty acid, glycerol, ester linkage. This is glycerol and fatty acid. These linkages may be broken down and the fatty acid may be released from here, and the carbon skeleton will be produced as glycerol, and the three fatty acids will be separated from each other, and for this reason they are called free fatty acids. This condition may be happened if you keep your fat in unhealthy condition. Then the lipase enzyme from the bacteria, it may affect on the fat, or in presence of the superheated steam, alkali or acid, in presence of water, 3 molecules of water, the triacyl glycerol or fats and oil may be hydrolyzed to produce glycerol and free fatty acids. So this properties is only shown by the fats and oil, and without applying this agent, you cannot get the glycerol and fatty acid. For this reason, these are the chemical properties of fats and oil. Then saponification. Saponification, this term, this is called alkaline hydrolysis. This is called alkaline hydrolysis. In presence of alkali, the fatty acids or fat is hydrolysis into glycerol and fatty acids. Then the fatty acids that are acidic in nature, and this acid may reacting with the alkali. The acids may react with alkali, and we know acid plus alkali equal salt and water. So this salt that is produced, this is the salt of fatty acid, and this salt is called soap. I repeat, saponification is the process, the hydrolysis with alkali, not hydrolysis with water and enzyme. This is hydrolysis with alkali, and in presence of alkali, the ester linkage of fat is broken down, and firstly glycerol and fatty acids will produced. Then the fatty acid will react again with the alkali, and acid and alkali equal to salt and water. The salt is salt of fatty acid, that is called soap. So the process by which soap is prepared, this is called saponification. It is industrial definition, but in biochemistry, you have to define this saponification. This is alkaline hydrolysis of fats and oil to produce glycerol and salt of fatty acid. This is called saponification. So this is the properties of fat. In presence of alkali, fat may be saponified to produce soap or salt of fatty acid. Soap causes emulsification of oily materials. Soap can clean your dirty clothes due to the presence of this property saponification. When you use the soap on your dirty clothes, then the emulsion of fatty acid and the water is produced, and for this reason the fatty acid like dirt that is present in your clothes, it is removed from your clothes. So this is called emulsification. Emulsification means different properties of materials or liquids when mixed with each other, but no true mixture is produced, but a intermediate mixture is produced, that is called emulsification. Like water is polar, non-polar, but fat is polar. So when water and fat, this is organic and inorganic materials, they are not same properties. When you want to mix, so this is emulsion or emulsification that is produced between the two different types of the component. One is water, and this is inorganic solvent, and fat, that is inorganic solvent. So as the hydrolysis, saponification reaction is more or less similar, but in case of the hydrolysis, there was 3 molecules of water, but here 3 molecules of alkali. This is sodium hydroxide. In presence of this alkali, the product was glycerol, and there it was the free fatty acid. But when these fatty acids are produced, then the sodium hydroxide will reacting again with these 3 fatty acids, and sodium salt of the fatty acids is produced over here. So if it is palmitic acid, this is sodium palmitate. If it is stearic acid, then it's sodium stearate. If it is oleic acid, then this is sodium oleate. So these are the salt of the fatty acid and different names based on the fatty acid present here. If it is palmitic acid, this is sodium palmitate. Stearic acid, sodium stearate. Oleic acid, this is sodium oleate. All of these components, this is salt of fatty acids, are same properties, and that's bears the properties of the soap. So these are called the soap. And additionally, glycerol is produced over here. So this is saponification. As a compound will be fats or oil, so it must have to show these properties, saponification. Then halogenation. Halogenation is a properties that is shown only the unsaturated fatty acid. Unsaturated fatty acid can show this halogenation only. We know the halogen group, that is iodine and others, but here we will count the iodine only. This iodine can be incorporated at the double bond of the unsaturated fatty acid. This is the halogenation. Halogenation is the properties that is shown only by the unsaturated fatty acids, as it has the different double bond, one or more. And in this double bond, it can accept the halogen group, I mean iodine, and the double bond will be converted into single. It is very important properties to determine the degree of unsaturation. If a fat contains more and more unsaturated double bond, it will incorporate, but it will consume more and more iodine. And based on the number of iodine that is incorporated, but that is accepted by the unsaturated fatty acid, the number of double bond can be easily measured. A fat or fatty acid that contains only one double bond, if it contains X gram of the iodine, if it contains 2 double bond, then it will consume or it will accept 2x gram of the iodine. So from this 2x gram, you can easily assume that the unsaturated fatty acid contains 2 double bond. So if it is 3 times, it contains 3 double bond. 4 times, it is 4 content. So when the double bond is increased in the fat, the biological value and the commercial value of the fat will be increased. So it determines the biological value, because only one double bond that is incorporated in the unsaturated fatty acid, it is not usable or it is not valuable for you, because your body is sufficient enough to produce this unsaturated fatty acid by yourself. But when it contains 2 double bond, then it have the biological value, because it cannot be produced in your body. You have to consume it from the external source. So you have to look for the source that contains the double bond, 2 double bond containing fatty acids, or 3 or 4 double bond containing fatty acids, because they are very much important for the production of the cellular and subcellular membrane of the cell. So it contains it determines the biological value also. So this is the process by which the iodine is incorporated at the double bond. You observe over here, this is linoleic acid. It contains two double bonds. One is 9 and 10, another is 12 and 13. When two iodine is added here, then this double bond is converted into single bond, and two iodine is accepted by these two hydrogen, and another two hydrogen is iodine is accepted by these two hydrogen. So it was previously unsaturated fatty acids contain double bond. These two double bonds is incorporated into single double bond. So it was previously unsaturated due to presence of this double bond, but now it contains no double bond, so it acts as the saturated fatty acid. So previously linoleic acid was liquid in room temperature due to presence of this two double bond, but now as it doesn't contain any kinds of double bonds, so it is converted into solid as the saturated fat. So to convert the unsaturated fat into saturated fat, this halogenation is used here, and these properties can only shown by the unsaturated fatty acid. So these are the chemical properties of the fat. Then hydrogenation, as the halogenation, if it is not iodine, but if it is hydrogen, then it will hydrogen, and it will hydrogen. So it will be CH2, and CH2. So previously it was unsaturated fatty acid, but when CH2 is present all over the chain, there is no any double bond, so it will convert it into saturated fat. So this will be hard and hard. It was liquid and it will be hard. So to hard the liquid fat into solid fat, this properties that is applied, this is called hydrogenation. Instead of iodine, here hydrogen is applied. So accept hydrogen at the double bond under high pressure and catalyzed by finely divided nickel or copper and heat. It is not usually happened in the nature. Otherwise, if it is happened in the nature, all of the unsaturated fatty acid will be converted into saturated. So it is not natural process, but in some cases in industrial use of the saturated fatty acid, some portion of the double bond is converted into single, to make the fat hard. For this reason, it is happened, and it is done under the high pressure and catalyzed. This reaction is catalyzed by the nickel and copper and heat. So high pressure, heat, and the catalyzed will be nickel or copper. Then the hydrogen is incorporated at the double bond of the unsaturated fatty acid, and the double bond will be converted into single. So that fat that is produced due to the saturation of the double bond, this is called margarine. It is called margarine. That is, this is oleic acid is 18 carbon. Oleic acid is 18 carbon. We may recall it. It is a monounsaturated fatty acid. It is oleic acid. It contains only one double bond, that is at the carbon number between the carbon number 9 and 10. If hydrogen is incorporated here and the double bond between 9 and 10 is converted into single bond, then it is resembled to the stearic acid. So previously oleic acid was liquid, but stearic acid is solid. So you can easily convert this oleic acid into stearic acid under pressure, nickel and copper, and heat. So oleic acid is very available because soybean oil is very available. It is about 120 taka kilo, but 1 kg solid fat, saturated fat, is very costly. It is very costly. So you can convert this oleic acid into stearic acid easily by incorporating the hydrogen at the double bond. So liquid fat is converted into solid fat. This is called hardening. And this margarine is produced, and this margarine can be kept at the ambient temperature, open place, long time. It will be not destroyed by the bacteria or other components because it has no any double bond. The double bond that is present in the fat and oil, the hydrolysis as well as other broken down, that is happened at the double bond, and the fat may be broken down, and fat lost its properties. For this reason, stearic acid or saturated fat, it has no any double bond, so there is no any chance to attack the bacteria or other components to break down the fat. For this reason, the oleic acid is converted into stearic acid. আমরা জানি যে unsaturated fatty acid যে ডাবল বন্ড থাকে, এই ডাবল বন্ড গুলোতে সাধারণত তোমার ব্যাকটেরিয়া বা আদার্স যে কম্পোনেন্ট গুলো আছে সেগুলো অ্যাটাক করে এবং এই ডাবল বন্ড গুলো ভেঙে যায়, আর ভেঙে গেলে ফ্যাট তার যে ফ্যাটি অ্যাসিডের যে প্রপার্টি সেটি হারিয়ে ফেলে। তো যদি কোনো অবস্থাতে সেই ডাবল বন্ড গুলোকে সিঙ্গেল করে দেওয়া যায়, সেক্ষেত্রে ডাবল বন্ড থাকলো না, তার মানে এখানে ব্যাকটেরিয়াল অ্যাটাকের সুযোগ কিন্তু থাকলো না, আর সুযোগ না থাকার কারণে এগুলো অ্যাটাকও ঘটবে না, আর ফ্যাটটা অনেকদিন ভালো থাকবে। এই সুবিধার জন্য অনেক অসাধু ব্যবসায়ী আছে যারা সাধারণত তোমার এই অলিক অ্যাসিড গুলোকে স্টিয়ারিক অ্যাসিডে কনভার্ট করে বিভিন্ন প্রকারের ক্রিস্পি সাবস্টেন্স যেগুলো আছে, যেমন ধরো যেমন বিস্কুট, চানাচুর ইত্যাদি, এই সাবস্টেন্স গুলো তৈরি করে থাকে, স্যান্ডউইচ, বার্গার, সিঙ্গারা, পুরি ইত্যাদি তৈরি করে থাকে যাতে এটি নষ্ট না হয়। Anyway, this is margarine that is produced from the liquid oleic acid into stearic acid. This change of this fat that is used for the production of the margarine, and this margarine is used in different bakery substance to keep it long time. But don't get all. If a fatty acid contains 3 double bond, you may saturate it only 1 or 2 at least, but 1 should be free. If you convert all of the double bond into single, then the fat will be so hard that it will be difficult to digest. So it will be difficult to digest and we will not get any kind of nutritive value from this fat. So it is recommended not to convert all of the double bond into single. So this is the process. This is unsaturated fatty acid. Previously we discussed here 2 iodine, and this 2 iodine was incorporated here and here, here and here. But instead of this iodine, if you add hydrogen, then the same reaction will be happen, and this sorry, there is a phone, একটা phone আসছিল যার কারণে সেটা অ্যাটেন্ড করতে আমার দেরি হলো। Anyway, so this is the same reaction, that is hallucination and hydrogenation. So previously it was unsaturated fatty acid you observed here. This is oleic acid or linoleic acid. Suppose linoleic acid, it is 80 carbonate. So when this 2 double bond is converted into single in presence of the hydrogen, the carbon number is same but double bond position is changed. So carbon number as it is same, so it is from the stearic acid. So carbon number is 18, so this is stearic acid. So this is the change of the double bond into single in presence of the hydrogen under high pressure, copper or nickel or heat. So this is called margarine. So in exam, you may be asked about this one, what is margarine and why it is, how it is produced. So you have to answer by this way. Margarine is a change of the oleic acid into stearic acid. Oleic acid into stearic acid in presence of high pressure, nickel is catalyzed and the heat. So this is the hard fat that is produced from the oleic acid and is converted into stearic acid in presence of high pressure, nickel or copper and heat. So previously it was liquid and now it is solid, and it is used different types of bakery substances. This is biscuit, chanasu, chips, etc. Why? Because if it is in the same, this is the unsaturated condition, there is a bacterial lipase may attack to this double bond and fat may be broken down. And if this fatty acid is broken down in this position or this position, this fatty acid will lost its properties. You cannot use it as fat or fatty acid. So to avoid these disadvantages, this available fat, if it is hardening or if it is converted into solid by this hydrogen, then this same cheap fat will be converted into costly fat, and as it is saturated in condition, so there is no chance to attack the bacteria as like as it has any double bond. So this is the important of the margarine. The hydrogenation and hallucination, it has some advantage, you know it, because you know solid fat is very pleasant, but liquid fat is not so. Solid presence very well. So for this reason, for animal fat, that is very much acceptable by all of them, but liquid fat, that is soybean oil or mustard oil, etc., it is not so pleasant. But pleasant is the animal fat, that is solid. For this reason, the liquid fat is converted into solid. Digestible and utilizable, but you have to remind that not all of the double bonds should be converted. In a certain portion, 50% or 75% may be converted, but others 25% or 50% should be kept as is. If it can keep it so, then the fat that is margarine that is produced, it will be utilizable or it may be digested by the living organs. Otherwise, if all of the double bond is converted to single, it will lose its digestibility capacity. Less reliable or gastric or intestinal irritation. If some person is suffering from these types of different types of the diseases due to the consumption of the unsaturated fatty acid, so if this person take only this converted fat that is produced from the unsaturated fatty acid, maybe it will help him to reduce the gastric or intestinal irritation, as it is happened due to the presence of the unsaturated fatty acid. Then easily stored and transport less level to density, we have already discussed. That is, if a fat contain double bond, then bacteria and others agent can attack to this double bond and fat may be destroyed. This is called density. Fat may be destroyed or broken down. This broken down fat has no the real or true properties of the fat. And when a fat lost its properties, then this fat is called rancid fat, and this is called rancidity. So when you convert this liquid or unsaturated fatty acid into saturated or solid fat, then there is no any double bond. For this reason, no double bond present, no bacterial attack will be occur. And for this reason, no broken down of the fat will be occur. And for this reason, it will not produce any rancid fat. For this reason, it is less liable to the rancidity. And you can easily store it in any kinds of place, and it is stored easily because due to the dramatic shaking, some double bond may be broken down also. As it has the double bond, so you can easily store it, transport it at any place, as there is no any chance to make or to happen any rancidity. Disadvantages, we know fats and oil are organic in nature, and there is essential vitamins, vitamin A, D, E, and K. These essential vitamins are also organic in nature. So in different source, that is essential vitamins means these vitamins are not produced in your body. So you have to take it from the external source, and in external source, as it is lipid-like solution, so it will dissolve in lipid. So you take it from the soybean oil. Suppose there is a source of the vitamin A, and this vitamin A is dissolved in the soybean oil. But after taking this soybean oil, you converted it into, that is oleic acid that contains the vitamin A, but you convert this oleic acid into the stearic acid. When this stearic acid is produced from this oleic acid, then there is no chance of the fat to be dissolved in this oleic acid. For this reason, you take other kinds of the fat, but the vitamins, the essential vitamins will be lost. So this is called lack of fat soluble vitamins, essential fatty acids, etc. Oxidation. This is the another properties of the fatty acid. I have already give you some hints about the rancidity. When the double bond is broken down, or other any kinds of the abnormal situation that is produced in the lipid, that is called rancidity, that hamper the original properties of the lipid, physical properties. About we have discussed about the physical properties. The freshly prepared fats and oil has no any color, odor, or taste. So when a fat is converted into rancid fat by different types of agent, then the fat will lost its original color, odor, and taste. You will observe there, freshly prepared fat, it was the colorless, odorless, or tasteless. But if it is rancid, then it will contain some color, contain some odor, contain some taste, and that fat is called rancid fat, or this is called rancidity. So these physicochemical changes of fat leads to unpleasant odor, taste, or color of oils and fat. This is called rancidity. I have already said the freshly prepared healthy fat has no any color, has no any odor, has no any taste. But if any kinds of changes happen, suppose the double bond is broken down or others, then the fat will change different types of color, odor, and taste. This fat is called rancid fat, and the process, this is called rancidity. It is happened due to the presence of oxygen, bacteria, fungal contamination, light, temperature, moisture, agitation, acid, alkali, etc. Due to the presence of these types of agents, the fat may be converted into abnormal color, odor, and taste. This is called rancidity, and this is called rancidity agent. So what are they? রেজোয়ানা আফরিন, কি সমস্যা? রেজওয়ানা আফরিন, saturated fat resists rancidity because saturated fat has no any double bond. Saturated fat resists rancidity because saturated fat has no any double bond. But unsaturated fatty acid has double bond. So in the double bond, there may be contamination of fungus, bacteria, etc. There may be incorporation of the oxygen, hydrogen, etc. That may be broken down due to the presence of abnormal light, temperature, moisture. But saturated fat has no double bond. For this reason, there is no chance to attack by this agent. For this reason, rancidity is tolerated by the saturated fatty acid more than the unsaturated fatty acid. Example is linseed oil, which is used in the paint varnish manufacturing. Linseed oil, it is unsaturated fatty acid. But if the rancidity is happened on this linseed oil and it is converted into converted in abnormal color, taste, or odor. That is called rancid fat. This fat cannot be used for the consumption. Otherwise, instead of consumption, it has to be sent to the paint and varnish industries to make the paints and varnish. So the rancid fat that is produced usually, it is beyond the use of the consumption. Then it has to be sent to the different types of industries like paint, varnish, soap, etc., where this rancid fat is used to produce different types of industrial components. So this is another property. This is oxidation or rancidity. There are different types of the rancidity. This is hydrolytic rancidity, ketonic rancidity, and oxidative rancidity. So three types of rancidity is present. Hydrolytic rancidity means in presence of hydrogen, in presence of water, the lysis will be observed. Oxidative rancidity means there is a scope to incorporate oxygen, and ketonic rancidity means there is a scope to break down the double bond. So we will discuss all of them. So first is the hydrolytic rancidity. It is hydrolysis. Why it will be hydrolysis? This hydrolysis will be happen at the ester position, at the esteric position. You know, lipid and fat, that is the esterified product of the fatty acid and glycerol or alcohol with the ester linkage. So this is the healthy fat. I repeat, a healthy fat contains fatty acid and glycerol or alcohol. That is esterified. That is esterified product of the fatty acid and alcohol. The carboxyl group and hydroxyl group is linked with each other by a ester linkage. This is healthy fat. It has been incorporated. All of the three fatty acid will be incorporated at the glycerol carbon skeleton. But if one or more fatty acid is liberated or removed from this skeleton, then the fat will declare as the unhealthy fat. So it will occupy some kinds of the color, taste, and odor. So this is called rancid fat. So this rancidity is called hydrolytic rancidity. If different agent, maybe bacterial agent, fungus agent, heat, temperature, etc. If by the presence of this agent, if the ester linkage is broken down and fatty acid is removed from this, then this process is called hydrolytic rancidity, and the product will be free fatty acids and glycerol. This is called hydrolysis of the fat, and usually it is happened due to the presence of the lipase from the bacterial contamination. If you preserve your fat in abnormal situation like unusual temperature or unusual moisture condition, then the bacteria of the environment will attack to the ester linkage of the fat, and the fatty acid and glycerol will be separate from here, and then the fat will lose its original or healthy properties. This is called hydrolysis or hydrolytic rancidity. It is happened due to the high temperature and moisture, because these two conditions is very much favorable for the bacterial reproduction and growth. Volatile short chain fatty acids are more vulnerable. Volatile short chain fatty acids are more vulnerable to the hydrolytic rancidity. This is as the saponification or hydrolysis that we discussed about when we discuss about the chemical properties. On number one chemical property, this is hydrolysis. This is same reaction where this in presence of three molecules of water, lipase enzyme from the bacteria or fungus that attack this ester linkage, and all of the three fatty acids are removed, and the glycerol is produced. If it is happened abnormally in the stored fat, then this process is called hydrolytic rancidity, and it is not fat because the fatty acid and glycerol is separated from here. So this is not fat. This is fat, but this is not fat. So fat lost its original properties. So this fat is called rancid fat. Oxidative rancidity, addition of oxygen at the double bond of the unsaturated fatty acid. This is happened. This ketonic rancidity and oxidative rancidity happened at the unsaturated fatty acid, where the double bond is present, and at the double bond the oxygen may be incorporated, and the fat will convert it into different types of peroxide product. When exposure to the oxygen, light, or heat, then different types of peroxide derivatives it is produced, like peroxide, aldehyde, ketones, dicarboxylic acid, etc. This is peroxides aldehyde, ketones, dicarboxylic acid, etc. is produced. That is have the bad odor, bad color, and bad taste. So when a fat contains bad odor, bad taste, bad color, this is called acidity, and it is oxidative acidity because the ketonic or peroxide substance is produced here as the oxygen is incorporated at the double bond of the fatty acid. And another kinds of density that is called ketonic density. This is polyunsaturated fatty acid. This is unsaturated fatty acid. When oxygen is incorporated here, peroxide radical is produced. Then it is converted into cyclic peroxide, hydroperoxides, aldehyde, hydroxy fatty acids, and other dicarboxylic acid, etc. These products are produced due to the incorporation of the double bond at the double bond position of the unsaturated fatty acid. And this product that is produced from this polyunsaturated fatty acids, it is very much toxic for the human body. For this reason, this is the oxidative density is very harmful for the animal body. And another kind, this is ketonic density. Ketonic density is also happened at the double bond position due to the contamination of certain fungi like Aspergillus niger. It is happened due to the contamination of the Aspergillus niger, and example coconut oil and others fat. Others fat due to the contamination of this fungus. This ketonic density is happened at the double bond of the unsaturated fatty acid, and the products, that is ketones, fatty aldehyde, short chain fatty acid, fatty alcohols, etc. Or the double bond is broken down, and when this double bond is broken down, then aldehyde may be free, short chain, some sort of short chain fatty acids may be produced, fatty alcohol may be produced, ketones may be produced, and these components are very much toxic for the human body. So this is ketonic density. So this is ketonic density, and you know the density is happened due to the preservation of the fat in abnormal moisture, temperature, and light condition. So it is happened when you keep your fat at the abnormal moisture condition. This moisture can accelerate the ketone density because where the moisture is abnormally increased, there the fungal contamination will be also increased. So as the Aspergillus niger production will be increased, so the ketonic density will also increase here. Preservation of residity acid by prevention. How can you prevent? The causative factors, the factors that are very responsible for the acidity, you have to avoid them. You have to avoid them. Avoidance the causes. We know the abnormal preservation of the fat, the abnormal light, temperature, heat, bacterial contamination, etc., etc. These are the physical agent, and due to the presence of this agent, the fat is to be rancid. For this reason, you have to avoid it. So on the packet of different types of product, you will observe that it is written over here, please keep it under 20 degrees Celsius temperature in dry and dark place to avoid this density. So it is এই জন্য এখানে লেখা থাকে যে এটাকে এরকম কন্ডিশনে রাখুন. So you have to avoid the causes that cause are responsible for the density. Then maintain good storage condition while closed containers in cold, dark, and dry place. If you can preserve your fat in this condition, you can avoid the density. Remember catalyze. The catalyst that is accelerate the process of density. During preservation of the lipid or fat, you have to remove this catalyst from this preserved fat. Otherwise, it will increase the density to help the different types of agent. Addition of antioxidant. This is oxidation. Different types of oxidation. So you have to use some antioxidant to avoid the oxidation. Like different types of synthetic and natural antioxidant is present. So if you want to store your fat for long time, you have to add some antioxidant. It is maybe natural or it may be synthetic. Artificial, this is phenol, naphthol, stannine, hydrogenation, etc. These are the artificial antioxidant that is prepared by the man. or scientists. So if you want to preserve your fat for a long time, you have to mix some sort of these components. And plants usually produce this natural antioxidant. This is vitamin E. In the natural antioxidant, this is vitamin E. So the oilseed plants like mustard, soybean, linseed, cotton, etc., that is used for the extraction of oils, it naturally produces this vitamin E and mix it to the oils to avoid the different types of unaxial oxidation, to save its oil from the attack of bacteria or fungus or from the oxidation. Plant itself produces vitamin E and mix it in the oil. For this reason, unsaturated fatty acid like mustard oil, it is used to preserve pickle instead of animal fat, because mustard oil itself has the vitamin E itself, so it can protect the oxidation, unusual oxidation. For this reason, we usually preserve our pickle in the unsaturated fat like mustard oil, not in the animal fat. Hazards of the rancid fat. Hazard. So you know the product of the rancid fat is toxic. So it is not beyond the consumption. It may cause food poisoning and cancer. Destroy fat soluble vitamins. We have already discussed about it. Polyunsaturated fatty acids that are essential. Then cause economical loss. Economical loss. Obviously, it cause the economical loss, because when a fat is declared to be rancid fat, so nobody will purchase it and nobody will consume it. So soybean oil, that is 120 taka kilo. If it is rancid, then no one will take it, no one will buy it. So it will cause the economical loss also. It will also biological value, it will also determine. So this class will stop just now. So if you have any question, we can discuss it. We have another 3 minutes also. তোমাদের যদি কোনো প্রশ্ন থাকে আমরা 2-3 মিনিট আলাপ করতে পারি। তোমাদের কারো কোনো প্রশ্ন আছে কোথাও? কিন্তু আমি তো তোমাদেরকে আনমিউট করে দিয়েছি। হ্যালো
স্যার, স্যার হাইড্রোজেনেশন আর হার্ডেনিং অফ অয়েলস, এটার অ্যাডভান্টেজেস গুলো আরেকবার একটু দেখান তো।
ওটা আমি বলেছিলাম যে যদি হার্ডেনিং করা হয় তাহলে একটা ফ্যাট যদি আনস্যাচুরেটেড থাকে তাহলে এটি তোমার রেনসিড হয়ে যেতে পারে, কিন্তু যদি হার্ডেনিং করা হয় তাহলে রেনসিড হওয়ার কোনো সুযোগ নেই। আবার বলা হয়েছিল যে যে সমস্ত লোকজনের আনস্যাচুরেটেড ফ্যাট খাইলে বিভিন্ন প্রকার সমস্যা হয়, ওই সমস্ত লোক যদি তোমার এই হার্ডেনিং ফ্যাটটা যদি খায় সেক্ষেত্রে হয়তো তাদের কোনো সমস্যা হবে। আরটা বলা হয়েছিল যে এটা প্লেজেন্ট, বেশ সুস্বাদু হয়ে থাকে। এই
ওকে স্যার।
স্যার রেনসিডিটির ডেফিনিশনটা একবার বলতে ভালো হয়।
রেনসিডিটি বলেছিলাম যে যে সমস্ত ফ্যাটগুলো তার ইউজুয়াল বা হেলদি ফ্যাট যে বৈশিষ্ট্যগুলো আছে, যে ফ্রেশলি প্রিপারেটেড ফ্যাটের তোমার কোনো প্রকার কালার, অর্ডার এবং টেস্ট থাকবে না, কিন্তু যদি এই সমস্ত ব্যাড কালার, ব্যাড টেস্ট, ব্যাড তোমার অর্ডার দেখা যায় কোনো ফ্যাটে, সেই ফ্যাটটা কি সাধারণত রেনসিড ফ্যাট বলা হয়। এর বিভিন্ন কারণ হতে পারে, সেই কারণগুলো আমরা আলাপ করেছি।
ওকে স্যার, থ্যাংক ইউ স্যার।
স্যার বায়োলজিক্যাল ভ্যালু
হলো তোমার, এটা হলো তোমার বায়োলজিক্যাল ফাংশন যে সমস্ত প্লে করে থাকে, যেমন তোমার ভিটামিন এ তোমার চোখের জন্য ভালো, ভিটামিন ডি তাই না তোমার হাড় গঠনে সাহায্য করে, ঠিক আছে না। এখন যদি তোমার বায়োলজিক্যাল ভ্যালু বলতে এগুলোকে বোঝায়, এগুলো ইম্পর্টেন্ট, কিন্তু যদি দেখা যায় যে তোমার একটা ফ্যাট এই সমস্ত পারপাস সার্ভ করতেছে না, তাহলে বুঝতে হবে যে এটা বায়োলজিক্যাল ভ্যালুটা নাই। একটু দাও তাহলে ধরে নিই। জি ভাই, শো দেবো। জি আপনি না আমি খাতা তো অবশ্যই দেখিনি, এখন দেখবেন, সমস্যা নেই, আমি আমার ওয়াইতে চেষ্টা করছি, যেহেতু এরা রিপিটেড স্টুডেন্ট। জি আচ্ছা, জি আসসালাম। হ্যাঁ, যদি আর কারো কোনো জিজ্ঞাসা থাকে আমরা এখন, অথবা
স্যার স্যার বায়োলজিক্যাল ভ্যালু কি শুধু এসেনশিয়াল ফ্যাটি অ্যাসিড গুলোরই থাকে?
না, নন এসেনশিয়াল গুলো থাকতে পারে। যেমন তো বায়োলজিক্যাল ভ্যালু বলতে বলছে যে সাথে এনার্জি প্রোডাকশনের জন্য খাদ্য ব্যবহার করা হয়। আর দেখা গেল তুমি যে ফ্যাট খেলে সেটা এনসিড ফ্যাট, পারক্সাইড তৈরি হয়েছে, এটা তোমাকে এনার্জি তো দেবেই না, বরং তোমার ক্যান্সার বা বিভিন্ন প্রকার রোগ বিপদ সৃষ্টি করবে।
স্যার আরেকটা প্রশ্ন, স্যার রেনসিডিটির ক্ষেত্রে কি শুধু ডাবল বন্ডে অ্যাটাক করবে নাকি শুধু
না,
অ্যাস্টার বন্ডে?
তিন প্রকার রেনসিডিটি ছিল না,
জি স্যার।
হাইড্রোলাইটিক, কিটোটিক এন্ড অক্সিডেটিভ। তো তিন জায়গায় করতে পারে।
ওকে স্যার।
স্যার লাস্ট স্লাইডটা কি একটু দেখাতে পারবেন?
বলো কি সমস্যা? আমি সমস্যা জিজ্ঞেস করছি, স্লাইড দেখাতে কত বলিনি। সমস্যা কি তোমার বলো।
স্যার লাস্ট পয়েন্টটা স্যার একটু স্যার বুঝতে স্যার প্রবলেম হচ্ছে।
আমি বলেছিলাম যে ভিটামিন এ যেটা, মানে ভিটামিন গুলো যেটা, সেটা এখানে ইনকর্পোরেট হবে না, ঠিক আছে?
আচ্ছা স্যার।
আর কার কোনো জিজ্ঞাসা? ইকোনমিক্যাল লসের কথা বলা হয়েছিল লাস্টে, ঠিক আছে? ইকোনমিক লস তো বলছিলাম যে এটা যদি ইউজই হবে না, তাহলে ইকোনমিক লস তো হবে। ওকে, যদি আর কারো জিজ্ঞাসা না থাকে আমরা স্টপ করি, বিকজ আরেকটা ক্লাস তোমাদের মনে হয় পরে আছে নাকি?
জি স্যার।
ক্লাস আছে?
জি
স্যার।
ওকে, ঠিক আছে, তাহলে সেই টিচার হয়তো অপেক্ষা করতেছে। ওকে, আল্লাহ হাফেজ, ভালো থেকো সবাই।
আসসালামু আলাইকুম।